Welcome to Chapter 7, Ionic Equilibria, Acid and Bases. Our first objective is to define the acid and base according to the Arrhenius, Bronsted, Lowry, and Lewis theories. According to Arrhenius theories, which you have learned, acid is a substance that produces H plus or H3O plus, or we call it proton or hydronium ion, when it dissociates in water. For example, as HCl, hydrochloric acid. We know that it is acid because it produces H plus or H3O plus when it dissociates. Okay. For base, is a substance that produces OH minus when it dissociates in water. For example, we know that sodium hydroxide is a base because it releases OH minus. Okay, according to Bronsted-Lowry theory, acid is a base that donates a proton to another species. Okay, what does it mean here? Let's have a look. Okay, for example, NH4 plus is an acid. Okay, why do we say that NH4 plus is an acid? Okay, we can see here, before reaction, it is NH4 plus. After reaction, it becomes NH3. So initially it has 4 hydrogen. After the reaction, it becomes 3 hydrogen. So 1 proton has been donated to another species, that is the base. So according to Bronsted-Lowry theory, base is a species that accepts a proton from another species. Okay, so means that water initially has 2 hydrogen. Okay, since it is a base, it will accept a proton. So it becomes 3 hydrogen. The last one is Lewis theory. Lewis theory states that a species that accepts a pair of electrons. Okay, now we say a pair of electrons to form dative bond. Then base is a species that donates a pair of electrons to form a dative bond. Okay, so let's look at this. So now NH3 has 1 lone pair. So it can donate 1 pair of electrons to BF3, which has empty orbital, to form dative bond, which we have learned in previous chapter. Okay, now let's revise again. Our prior knowledge is that Arrhenius acid is a substance that produces proton or hydronium ion when it dissociates in water. Okay, so you can see that sometimes we have H plus, sometimes we have H3O plus. Okay, so when are we going to use H plus? When are we going to use H3O plus? Okay, so chemists use the notations H plus and H3O plus interchangeably to represent the hydrated proton responsible for the characteristic properties of aqueous solutions of acids. Okay, thus, for this chapter, for this lesson, okay, for strong acid and strong base, strong acid we will be using H plus. If it's weak acid, then we will use H3O plus. Okay, now let's look at another one. Okay, Bronsted-Lowry theory. The emphasis in Bronsted-Lowry theory is on the proton transfer. It applies to aqueous solution and also gas too. If we look at Arrhenius equation will emphasize that it must dissociate in water. Okay, now let's look at this. If we have ammonia and hydrochloric acid, how do we know that which one is acid, which one is base? If the product has no H plus or OH minus. Okay, thus we can see here the Arrhenius theory cannot explain the acidity or basicity of this reaction because no proton and hydroxide ion is present in the reaction. And then this arrow, we will be using reversible arrow because it will, these two species will react again to produce ammonia and HCl. Okay, now let's look at what defines them as acid or base. Okay, if it's Bronsted base, the definition is it will accept proton. Okay, how does it accept proton? Okay, we know that HCl have H plus, Cl minus. So one lone pair here will accept the H plus. So it becomes NH4 plus. Okay, so same thing again, NH3, NH4 plus, we can see that the hydrogen has increased. Okay, but we don't say hydrogen, we say that accept proton. Okay, so when it accept proton, means that we know that it is Bronsted base. Okay, another one is Bronsted acid. Okay, Bronsted acid donates a proton. Okay, so if we see here HCl, then the final product only becomes Cl negative. So meaning that one hydrogen has been donated, or we can see that one hydrogen has been missing, but we don't say hydrogen, we say one proton has been donated. Thus, HCl will be the acid. Now, let's look at another one which reacts with water. Okay, so HCl, we know that it is a strong acid. Okay, so we just want to know, water is base or water is acid in this case. Okay, in this case, let us have a look at the equation. Okay, what happens to HCl is, we know that HCl and then only Cl left. So meaning that it donates a proton to H2O. And then H2O accepts a proton from HCl. So if proton acceptor, it is Bronsted base. If it's proton donor, then it is Bronsted acid. Okay, so how do we know that it is acidic? Because of the hydronium ion. It is the characteristic properties of aqueous solution of acids. Okay, now let's look at another one. Okay, a Bronsted base is a species that accepts a proton from another species. So Bronsted base is proton acceptor. Now let's look at what happened. Okay, we have one lone pair, so it will accept one proton from H2O. So proton acceptor is base. Then for this one, we know it has H plus, OH minus. Now OH, H plus has been donated, so we say it as a proton donor. It is a Bronsted acid. How do we know that it is basic? Because of OH minus is the characteristic properties of aqueous solution of base. So in both cases, we can see that water can react as base. Water also can react as acid. Okay, so water can act as either acid or base. Okay, for example, if let's say if it's base, it will accept proton. Okay, accept 2 becomes 3. If it's acid, it will donate proton. 2 becomes 1. Okay, so a substance capable of acting as either an acid or a base is called amphiprotic, or we can say it has amphoteric. Okay, so once again, let's revise. Arrhenius theories is the substance that produce H plus or OH minus for acid or base. If Bronsted-Lowry, we are focused on donate proton or accept a proton. If Lewis theory, we focus on accept a pair of electron or donate a pair of electrons to form dative bond. That's all for the acid-base definition for chapter 7.